starting with the sine rule. Okay, now the sine rule states that in any triangle ABC, and you can see this triangle here, and just before I introduce this rule to you, you should know that this is the standard triangle that we always refer to when we get to the sine rule and the cosine rule. So this triangle has the angles of capital A, capital B, and capital C. So the capital letters represent the angles, and then the smaller case letters A, B, and C are the sides. And as you can see, the little a is opposite capital B, and little b is opposite capital B, and little c is opposite capital C. So they always correspond to each other, so make sure you know how they are positioned, okay? That's the triangle that we're going to refer to, and on that triangle I'm going to apply my sine rule. Now for those who are wondering, when do we apply the sine rule, why is it used? Well, you know, when we use Pythagoras, we can find another angle, or remember when we did the ratios of sine, cos, and tan? Remember the sine equals to opposite over hypotenuse, cos equals to adjacent over hypotenuse, and tan equals to opposite over adjacent, remember? So those ones, however, we can only use them when we have a right angle triangle, yeah? But when we get to triangles that are not right angled, what do we use? We then use the sine rule or the cosine rule. Okay, so that's why we use these two rules. So as you can see, that one's clearly not a right angle triangle. Okay, so this is it. So A, the side, okay, side A over sine capital A equals to B over sine capital B, and that's also equal to little c over sine capital C. Okay, or you can have it the other way around. You can have the sine A on top, so sine capital A on A, sine capital B on little b, sine capital C on little c. Doesn't matter which way, whatever's comfortable for the question. Okay, so depending on the question, you may like to use the side on top or side on bottom. Okay, whatever, both of them are fine. Now, you don't have to use all three. We usually use just two at a time, okay, because that's an equation that will get us to solve for any pronumeral. Alright, so that's it. Not too hard. Okay, try not to memorize all three, just memorize like this. That's perfectly fine. So have a look. That's the sine rule. Keep that next to you somewhere because we're going to be using this throughout the next few questions. So that's it. Let's keep going with the questions. Starting with question 1, find A correct to one decimal place, and this is our pronumeral here, A. Okay, so we need to know that side, so I'm going to apply my sine rule, but when we apply our sine rule, you should check. Do I have an opposite angle? Yes. And do I have another pair of opposite angle and side? See how this one here has an opposite angle and an opposite side, so we can apply the sine rule. Okay, if we don't have any one of those, we can't apply the sine rule because that means we have two pronumerals. So you get what I mean? So A over sine 29. So the angle in here must always be the angle that's opposite that side. So A over sine 29 degrees equals 2, and then you use another pair of opposite side and angle. So 17, which is this side here, over sine 68 degrees, and I've used that opposite angle for this one. So here the only pronumeral is A, so I can solve for it pretty easily. And as you can see, guys, I use the side on top, okay, and the angles on bottom. That's because all I need to do is simply multiply both sides by sine 29 degrees, just like this, and then I can have just A left on this left hand side. Okay, that's why I'm having my A on top. If I have it on bottom, I have to add extra steps, so that's a bit annoying, isn't it? So always start with the right one, and then I've got that. All you need to do now is put that into your calculator straight away, but just be careful, and you should get 8.9, okay, to one decimal place. And that's it, very easy, as long as you memorize it, very, very simple steps. Okay, that was question 1, hope that was understandable. Question 2, find Q correct to one decimal place, and as you can see there's Q, and just make sure before we start we have the opposite angle, which is good, and we need one other opposite angle and opposite side, a pair of those. And as you can see there's an opposite angle and an opposite side, matching sides and angles, so I can apply my sine rule. So let's go ahead, and as you can see I'm going to put my Q on top again, so my side's on top, so I can solve it more easily. So Q over the opposite angle, sine 52 degrees. Okay, and some people tend to forget sine for some reason, so make sure you always have that sine before the angle. So sine 52 degrees, and over here, this side 21 over the opposite angle, sine of the opposite angle. So sine 41 degrees. Okay, so that's what I did to apply the sine rule. Now I want Q, so we should multiply both sides by sine 52 degrees, and that will be eliminated on this side, so we simply have Q left on the left hand side. Can you see what I did? Just a bit of algebra, and all you need to do is again just put that into the calculator, check what you get, see if you get this answer, 25.2 to 1 decimal place. Okay, very, very similar to question 1. Question 3, find K correct to 1 decimal place. So again, we have K, we have the opposite angle, and we've got another pair of angle and opposite sides, so we can definitely use the sine rule. K, the side, over sine of the opposite angle, so sine 12 degrees. And that's equal to 13 equals to sine opposite angle of 80 degrees. Okay, so I just simply use the sine rule. And just before I keep going, guys, make sure you don't get this the other way around. Make sure the sides are always corresponding and the angles are always corresponding. Okay? Alright, so now all we need to do is solve for K. This denominator is sine 12 degrees. I want to eliminate that, so just simply multiply both sides by that denominator of sine 12 degrees. So I have K left on the left hand side, and I've got that sine 12 multiplied onto the right hand side. Put it in the calculator. This is what you should have. Very, very simple. So you should be getting very, very quick. 4. Okay, this time we're finding theta, which is the angle. Okay, as you can see, it's an angle correct to the nearest degree. Okay, so this time we're simply going to apply the same rule, but we're just looking for a different input, which is an angle this time, angle of theta. And again, do the same thing. If I'm looking for that pronumeral angle, I must have an opposite side. And see, I have an opposite side given to us, which is good. And we also need another pair of side and opposite angle. So side, opposite angle, we can apply the sine rule. So this is what I did. So this time, as you can see, I put the sine angle on top, okay, on the numerators, so I can solve for it more quickly. Okay, so I put sine theta on top, sine theta, and then I put that over the opposite side, which is 24. That's equal to sine 71 degrees over the opposite side, which is 28. Okay, so that's all you need to do. Alright, sine theta will be this multiplied by 24. We're simply multiplying both sides by 24 to eliminate that denominator, so I have sine theta left on this side. And if you calculate this, it's going to be something like this, 0.8104 something, because it's going to continue. And we're looking for theta. So to find theta, I'm going to have sine inverse of this value, okay? But make sure you don't round it up yet. Make sure you still use that exact value until we get to the final answer, so we have the accurate answer. And then just put that into your calculator and you should have 54 degrees, okay, to the nearest degree. Does that make sense, guys? And see how I use the sine rule to find the angle as well? So it's basically sine A on A equals to sine B on B. And you can tell which sides and angles are A and B. Okay, or capital A and capital B. Okay, so have a look. Even if we're looking for the angle, it's very, very simple. Question 5. Again, we're looking for theta, correct to the nearest degree. So here's theta. We've got an opposite side, which is excellent. And we've got another pair of opposite side and angle. So we can simply just use the sine rule. Just like that. So sine theta, okay, opposite the opposite side, sorry, on top of the opposite side, equals to, now we've got this other pair, so sine 66 degrees over the opposite side, which is 39. Okay, so I'll just apply the sine rule, and then from here it's just algebra, yeah? So multiply both sides by 11 to eliminate the denominator here, so I simply have sine theta left on the left hand side. This is my right hand side. I'm just going to put that in the calculator. You should have 0.2576, etc. So sine theta equals to this. So to find theta, we have to inverse sine, don't we? So sine inverse of that value there. And again, don't round this up, guys, yet. Okay, so put that exact value inside your calculator. And then you should have 15 degrees as your theta, to the nearest degree. Okay, so make sure you know how to round it to the nearest degree. That's it. Alright, so very, very similar to previous question. Okay, find theta correct to the nearest minute. Alright, so this time we've got some minutes involved, but we'll just apply the same way. So we're looking for theta. I've got an opposite side, and I've got an angle here with the opposite side. So just simply use the sine rule, just like this. So sine theta here, on top of the opposite side, which is 60, equals to sine angle, which is this angle here. Just put all the minutes as well over the opposite side, which is 27. Okay. And I hope you guys know by now why I put the sine theta on top, okay, because it's much easier to solve. Alright, now multiply both sides by 16, so I have sine theta left on my left hand side. Put this in your calculator and just check what you get. I've got 0.462 something. And we need to find theta, so simply press sine inverse your answer, which is going to be something like this, and just find your answer. It's going to be to the nearest minute, so 27 degrees and 31 minutes. Okay, and make sure you know how to round it to the nearest minute as well. Okay, and that's the answer, so go and check. And let's move on. Okay, find ln, correct to 3 significant figures. This is ln here. Okay, so that's ln, so we're going to look for that side. So we're not looking for the angle, we're looking for the side. And we've got ln, so make sure we have an opposite angle. Yes, we do. Now look guys, I need another pair of opposite side and opposite angle, but I've got an angle and a side, but they're not opposite each other. What are we going to do? We can't use the sine rule straight away, so what are we going to do? Well, we know that this one we're going to use because we have to look for ln. We've got a side and we've got an angle, so we need either a opposite side for here or we need an opposite angle for this one. But we can't find this side, right? There's no way we can find this side. But how about we look for this angle here? This angle here, so we can have the opposite angle for this side. Do you know how we're going to do that? Well look guys, we have one angle, we've got another angle. So to find the third angle, what do? Angle sum of a triangle. So angle MLN, which is this angle here that we're looking for here, is going to be 180 degrees because angle sum of a triangle is 180 degrees. So 180 degrees minus these two angles. So minus 58 and 74, you should get 48 degrees. So this one here is 48 degrees. Okay, so I've got an opposite angle for the side. So now we can apply the sine rule. So let's go ahead and do that. Okay, ln, which is this side here, over the opposite angle, okay, or sine opposite angle, so sine 58 degrees equals to 89.6 over sine 48 degrees, the opposite angle. Okay, so we don't need to use this angle anymore. Well, yeah. See what I did? And again, I put the side on top so I can solve for it more easily. Multiply both sides by sine 58 degrees. Put that into your calculator, and you should simply have 102 to 3 significant figures. Okay, see what you did? So some of these questions, they need some extra steps, just like we did here. We needed to find the other angle, right? But that's not a big deal. Let's move on. Find PQ. Okay, so we're simply looking for this side here. Okay, PQ. And just make sure I've got an opposite angle, which is good. And I've got another pair of angle and opposite side. So we don't really need to add any more steps. We just simply need to go straight to the sine rule. Okay, so PQ, this side over the opposite angle, or sine over the sine opposite angle. So sine 45 degrees equals to side, which is 10 root 2 here, over sine opposite angle. So sine 30 degrees. So we need to look for PQ. So multiply both sides by sine 45. And just put it in the calculator. That's all you need to do. Check. Just put it in your calculator, see what you get, and check with mine. I've got 20. Okay, that's all I got. So I hope you got that one. So check. That's pretty much what the sine rule is. So it's very easy. Sine A over little a equals to sine B over little b, and that's how I just remember it. I don't remember all three. Okay, see what I did?